Okay, let's talk about multiplying radicals. We've talked about how we simplify radicals, and we've done a lot of problems with those. And I'm going to do the same thing in this video that I did in the last video when we were simplifying. I'm going to be pulling some problems straight off the homework software because some of the ones on the worksheet I'm just not real thrilled with. When we're talking about multiplying, we are talking about multiplying two roots, and you can multiply roots if they have the same index. So we can multiply the same index. And when you do that multiplying, I want you to multiply outside times outside, meaning the outside numbers or variables outside the root, and then multiply inside or underneath the root. Okay, and then we'll do some simplifying. Now, when we do the multiplying, you might use the distributive property. Pen kind of went a little nuts there for a second. The distributive property, or we may FOIL, depending on if it's a 2 by 2. So we can use a couple of different ways to do this multiplying. So if you look at this first one, I've got cube root of 4 times cube root of 2, and I can multiply those because they're both cube roots. So I'm just going to multiply what's underneath and get cube root of 8. Well, if you look on your perfect cube page or perfects page that I told you to print off, you would see that 8 is a perfect cube. So that means that this is going to simplify, and that 8 is going to come out because it's a perfect. It's going to come out as a perfect 2 because the cube root of 8 is equal to 2. So sometimes they're just as easy as that. If you look at this next one, that is a 4. That is cube root of 4 on the outside times a cube root of 2 minus a 3. So on this one, I'm going to distribute because it's not just a one term times a one term. Cube root of 4 times cube root of 2 would give me cube root of 8, because 4 times 2 is 8. Now, the 3 doesn't have a root with it, so that counts as an outside 3. So when I take cube root of 4 times a negative 3, I get minus 3 cube root of 4. And then we see if we can simplify. Cube root of 8, we just talked about that in the problem before this one, that equals a 2. Okay? Now, you cannot take the cube root of 4, so I'm just going to be left with 3 cube root of 4. So I've got 2 minus 3 cube root of 4. So there's one where we do distributive property. The next one, C part, is a 2 by 2, so we could do a FOIL on it. And so we're going to do first times first. And I'm going to write underneath here what we're multiplying so you can kind of see it. Square root of 2 times square root of 2, well, that equals square root of 4, which is a perfect square, which is 2. And on a side note, if you multiply a square root times itself, the number underneath comes out. And you can see that that's true when I took square root of 2 times square root of 2. Ultimately, I ended up with 2 for an answer because it ended up being square root of 4, which is 2. So you can kind of take that shortcut if you recognize that. All right, we're going to do outer times outer, so that's a square root of 2 times a 5. So that is a plus 5 square root of 2. Inner times inner is a negative 1 times the square root of 2. So that's minus 1 square root of 2. And then last times last is a negative 1 times a 5, which is a minus 5. So now we're going to combine like terms. I've got a 2 minus a 5, so that's going to give me negative 3. I've got a 5 square root of 2 minus 1 square root of 2, so that gives me a positive 4 square root of 2. So a negative 3 plus 4 square root of 2 would be the final answer. This next one, I'm not crazy about it. Let's go on and do the one at the bottom. It's got a lot of square roots that look the same. This is actually a square root times another square root of binomials. We can FOIL it. And if you'll notice, this is called a conjugate. And what makes a conjugate is when you multiply two binomials that are exactly the same except for the sign in the middle. One's a plus and one's a minus. When we multiply conjugates, and we're going to do this later on, but when you multiply conjugates, you really just have to do the first and the last. I'm going to do all of the steps of FOIL, but you'll see what ends up happening is the O and the I part of FOIL, the outer and the inner, they end up canceling each other out, which is kind of nice. So first times first, square root of 5 times square root of 5 is going to give me square root of 25, which equals a 5. My pen kind of keeps jumping around. Okay, let me erase that because it kind of just keeps jumping, which I don't really know why. Let's try that again. Square root of 5, I'm going to write over that. I'm going to try a different color. That's going to give me a 5. All right, I paused there for a second trying to fix the pen. I'm going to see if it'll keep going. The next one's going to be outer times inner, outer times outer. So square root of 5 times a negative square root of 2. That would give me minus square root of 10. Inner times inner is a square root of 2 times the square root of 5, which would give me positive square root of 10. And then last times last, square root of 2 times a negative square root of 2 gives me negative square root of 4, which square root of 4 is a 2. So that gives me minus 2. So you can see those two middle ones canceled out. And on this one, it ends up being a 5 minus 2, which for a final answer would be equal to 3. So that kind of works out kind of nicely. We're not going to do this last one on this page either. So here's where I'm going to add some problems that I found on the homework, because I think that'll be a little bit more helpful to you. Here was one that I found on the homework. Let's try it. Square root of 3a squared times the square root of 6a to the 8th. My pen is just going crazy. Mark that out. 6a to the 8th. All right, so let's do that multiplying. 3 times 6 is going to be 18, and then a squared times a to the 8th. You add your exponents on multiplying. So I end up with 18a to the 10th. Now you have to see if you can simplify that. Well, I know that 18, it has a perfect square of 9 in it. So 9 times 2. So the 9 is going to come off as a 3 because the square root of 9 is equal to 3. The 2 stays. Then on a to the 10th, well, remember when you have exponents, you divide by, there's an imaginary 2 in that pocket. 10 divided by 2 would be 5. So an a to the 5th is going to come out. And I don't have any leftover a's. So this ends up being 3a to the 5th square root of 2. So that's one kind of like you'll see on the homework. What if we have more than one letter in there? What if we have 2v to the 6th x to the 5th times square root of 6v x to the x squared? So again, I'm going to multiply by numbers because they're inside times inside, so that gives me a 12. I'm going to add the exponents. I'm going to do x's first to get x to the 7th. And v, 6 plus 1 would be 7. So I end up with 12v to the 7th, x to the 7th underneath. So then 12, I know that 4 is a perfect square that goes into 12. So the square root of 4 is 2, 3 stays. So for x to the 7th and v to the 7th, I'm going to do the same thing on both of them. That's going to become x to the 6th times x to the 1. 6 divides by 2 3 times. So 3 of those x's are going to come off and the x to the 1 stays. We'll do the same thing with the v. V to the 6th, v to the 1. 6 divides by 2 3 times. So 3 of those v's come off and that v stays. So I had a 2x cubed v cubed come out. And then what I have circled stays underneath, 3xv. So that's how you would work that one. Okay, let's do another one that's a distributive property. Let's do square root of 3 times 7 square root of 6 plus 9. And this will be a distributive property, so I'm going to take square root of 3 times a 7 square root of 6. There's an imaginary 1 in front of that square root of 3, so when you multiply outside times outside, 7 times 1 is 7, and then square root of 3 times 6 will be 18. Okay, and then I'm going to take square root of 3 times a 9. Now remember that 9 is an outside number because it doesn't have it's not underneath the root. So 9 times 1 would be 9, and then I don't have anything to multiply that square root of 3 by. Now, once you have done that, let's look at 18. 18 is 9 times 2. So the square root of 9 is a 3. Any number that you bring out, you're going to multiply it times the number in front. So if I bring out a 3, 7 times 3 is 21. My pen is going crazy again. 21. And then the 2 is going to stay. I'm going to try and circle it. So 21 square root of 2. And then nothing happens with the 9 square root of 3. So there's my final answer. Doesn't always have to be get to be a pretty answer. So there's somewhere you had to FOIL. There's somewhere we did distributive property. There's somewhere we just had to multiply and simplify. So now let's look at the next page. Now this is kind of talking about something that I've already mentioned. If you multiply a square root times itself, for instance, this square root of 5 times itself, that's square root of 5 times square root of 5, which equals square root of 25, which equals 5. So a square root times itself just ends up popping out. If I have something like this 4 square root of 8 and I square the 4, that gives me 16. And then 8a, if I square root of 8a, the 8a pops out. So you're going to have something that looks kind of like that. And then I'm going to take 16 times 8. And then you're going to have your a with it. So this was kind of in two parts. I did the outside, and I squared it. That's where I got the 16. And then I did the underneath. And because the underneath is squared, it comes out. So 16 times 8 is going to give me 148a. Okay? I'm not going to worry about these next ones. Because I think that you're going to be just fine multiplying some of these out. The ones that are in the homework are not as involved as those that C and D at the bottom. But now I do want to talk about these at the bottom of the page. They call them special cases. They call them special cases. And all they are is if I talked about conjugates. And when I talked about conjugates, remember we just ended up multiplying the first and the last part of our FOIL. If we have one that's squared though, so parentheses squared, you need to write it out twice and then do the FOIL on it. I don't think there's any need to memorize these two parts right here. I think if you just write it out twice and FOIL it, you can't get it wrong. And so that's what I like to make all my classes do, is write them out twice and FOIL them. So I'm going to do just a couple of these on the back that I saw. Square root of 3 plus square root of 6 squared. I'm going to write it out twice. And then we're going to FOIL it. Now, you need to do all of the parts of FOIL on this one because these are not conjugates. These are exactly the same. So first times first, square root of 3 times square root of 3, that would be square root of 9, which equals 3. I'm going to try it and see if you can do that in your head this time. All right, outer times outer. Square root of 3 times the square root of 6 gives me a square root of 18. We'll simplify that in a second. Inner times inner. Square root of 3 times square root of 6 times the square root of 3 gives me another square root of 18. And then last times last, square root of 6 times square root of 6. Remember, if you multiply a root times itself, that number is going to come out. Now, I've got 3 plus 2 of these square root of 18s. Still need to simplify the 18 part. So I'm going to come over here. 18 is 9 times 2. We're not going to do this one down here, so I'm kind of taking its space. The square root of 9 is a 2. So I've got 3 plus 6. I'm going to go ahead and add those and get 9. And then on this one, a 2 came out. I already have a 2 in front of it. So you multiply those and get 4, and then a 2 stayed underneath. So 9 plus 4 squared to 2. I'm sorry. Square root of 9 is 3. I'm looking at my answer key and I'm like, that's not the right thing. That should have been a 6 to come out. So 2 times 3 would be 6 right here, and I just made a mistake. And I hope that you caught it as I was going along and asked yourself, why is she saying square root of 9 is equal to 2? Because square root of 9 equals 3. All right, let's do this last one. This one is a conjugate. And it's a conjugate. Why? Because they're exactly the same, but one has a minus and one has a plus. So on a conjugate, I just need to do the F and the L. Don't have to worry about outer and inner. So square root of 3 times square root of 3, that'd be square root of 9, which equals 3. Pen is going crazy. And then there's going to be a minus. And then square root of 2 times square root of 2 is square root of 4, which equals 2. And then 3 minus 2 equals a 1. So that one ends up being a 1, which is kind of handy. All right, so that takes us through some of the multiplying ones. When you get on your homework, let's look at this next page. We're not doing any of these that have the different indices in your homework, so you're not having to worry about those. And I apologize for the pen just going crazy. Be sure you email me with questions as you have questions about these square roots. Some of them can get kind of hairy, and I understand that. Some of them can get bigger numbers. If you have trouble figuring out what the perfect part of it is from the list, be sure and email me or text me or call my office. I'm ready to help you. Have a great day.